is the space we see on the sky is existing. When we look on the sky at night, we see numerous stars, distant galaxies. But when you're realizing you don't see them how they look right now at that moment, the ideas of not existing space come into your mind. What's happening with the space right now? Do we see the space in its past? Why? Let's talk about that. When you learn at school about the physics of light, that it takes time for light to travel, the first question we have is everything we see around us real? For example, when I see the tree on the top of the hill, there's a millisecond of the light traveling from the tree till my eye, so I can fairly sure say this tree is real. However, when I look at a very distant star, I see the light from the star coming to my eye through years or even thousands or millions of years. Does it mean the star exists? Although it's a scary thought, how actually it's happening? First, we need to understand how that light travels through the space. In the beginning of 20th century, the mastermind of physics, Albert Einstein, postulated that the light traveling through the space or any other medium is constant. The actual speed of light is constant. And when it travels through the space vacuum, it has particular speed, and we can count on it in our visible universe. However, the light is not instantly traveling from the source till the object. The beam of light, those particles of the electrons which vibrating, they produce quantum of light, how we can call them, non-mass particles which traveling through the space. And like anything else, like you have to walk from home till shop, it'll take time. Similar, these particles, they have to cover the distance between source and object which will see them and receive them. These particles will not going to transform any mass or any properties of the source. They will just emit the light or electromagnetic wave. And as any other wave, it will take time for this wave to reach the source, and only then we will see that object how it was in the moment of emitting this light. With the light, it's hard to judge for us, because on the planet Earth, the light, it seems like transmitting immediately all around our planet. However, there's other things like sound, which you can feel. It takes time for the sound wave to propagate through the space. If you've ever been in a big hall or in a gorge with the big tall mountains around you, you observe the echo. You scream something, and then the sound reflects from the walls, come back towards your ears, and you hear it with delay. Similar but on a faster scale happening with the light. So let's talk about the distances in the space then. For example, the brightest object till us, sun emitting the light, and we talked about it in previous videos. The distance from us till sun, we call it astronomical unit, it's equal to 8.3 minutes for light to travel. Therefore, next time you glance on the sun, please use sunglasses or protection to look at the sun. You see the sun just over 8 minutes ago. Therefore, we'll never will be able to look at the sun and say, oh, this is what's actually right now happening on the sun. They'll be always delayed. But luckily, 8 minutes, it's not just such a long time. So I can fairly assume that sun is okay right now. It was okay 8 minutes ago. We understand that the space is not clear vacuum, it's not pure vacuum. We assume it is, as a scientist suggested, and if you look in the space images, there's a lot of stuff in the space between stars, between sun systems, between galaxies. There is a lot of clouds and dust floating in the space, which will delay of the light travel. But nevertheless, we assume approximately light travels through the space and its constant speed. Bearing in mind the example of distance from us till sun, we can say that further planet in our solar system, Neptune, it's about 30.1 astronomical units away from the sun. Therefore, it's 29 astronomical units away from us. The distance till the Neptune varies, depends where we are on our orbit and where the Neptune on its orbit, but we can tell it took about over 4 hours for light to come from the Neptune towards us, observers on the Earth. Therefore, you can imagine, when we're looking on the Neptune, we see it's 4 hours ago. If something happened with the Neptune during the last hour, even 10 minutes, or last minute. We will see it in 4 hours. In astronomy, people use the light as the unit of distance because it's so many kilometers away, the closest star, the closest galaxy, or the age of our visible universe. Therefore, it's easier to use light years. Light years is the distance which light travels through the year. If we think it in astronomical units, it's about 63,241 astronomical unit, the time that the light travels through the year. For example, for Christmas till Christmas, that's the distance the light will travel. So why when we look in the space we see the past? Just because of that, because of this delay of the light beam to reach from the source till us, till our eye. And by the time it's passing through, the universe not standing, not waiting, it's evolving, changing, the stars evolving, they die, they disappear, the new solar systems forming. There's so much happening in space. Since then, the further we look in space, the more into the past we're looking at. Astronomers like this because we can see what's happening with other universe in the past. We also see how other star systems, galaxies evolving, and we can correlate it to our solar system and understand what's happened with us in the past. In the same time, there's limitations from that. Let's talk about the brightest star in our sky. It will be Sirius. Everybody know that. And the moment you see the Sirius next evening or morning, you understand that it's 8.6 light years away from us. It's exactly mean that you see the Sirius 8.5 years ago. The next brightest star in the sky in the southern hemisphere, for example, it will be Acrux in the Southern Cross. I see the Acrux right now on the sky, how it looked like in the year 1699. Or for example, the brightest star in the sky in Orion, Rigel, is about 800 light years away from us. The light we see on the sky right now, on the star, when you look at it, you see it how it was in the times of start of Middle Ages in Europe, time when numerous crusades were coming towards the Holy Land, in the times when there was no telescope even yet invented. If we look a little bit further, it's become more harder to understand the times we see right now. For example, the center of Milky Way galaxy, our galaxy, which according to the scientists we are located in, it's about 28,000 light years away from us. It's mean when we're looking towards the center of the Milky Way, which is in fact a huge black hole, which is black anyway and doesn't emit any light, but if you look in direction of the center of the Milky Way, you're looking at the times of it 28,000 years ago, just about the time when the last glaciation was occurring on our Earth. Most of the Europe, North America were covered with the ice. It gives you an idea what actually happening with the center of our Milky Way galaxy right now. Is it still at the same state we see it right now in our sky, or maybe it's not there anymore or something else happened? However, the fact that we are right now at that moment when we see it in the past existing on our Earth, it means that the physical world is still there, the galaxy probably is still there, and we as part of it, rotating around the sun, is still there. Andromeda is the nearest largest galaxy to us, the closest to the Milky Way, to our galaxy. It's about 3 million light years away. We see Andromeda how she was looked 3 million years ago, when humans was just evolving from our ancestors. The farther we look, for example, Perseus clusters composed of 500 galaxies, it's about 190 million light years away from us. All those 500 galaxies we see them almost 200 million years ago. Times of Mesozoic era striving on our planet. Very hot time for our planet. On the Earth there was still one big continent, Pangaea. And the farthest galaxies we see in the universe, they're about 15 billion light years away from us. Therefore, all these very distant galaxies we see on the moment of the formation of our universe. And as I said before, that it helps scientists to discover how our universe was formed and that it's expanding right now. And they can tell us that we can see the past. Everything we see outside of Oort cloud, our outer distance of our solar system, it's 1.2 light years. Please see a video about the age of our solar system. Therefore, anything we will see, other stars, galaxies, it will be the glance in the past. And the stronger your telescope, the more distant galaxies you see, the further back in the past you go. Doesn't mean we should be scared that maybe universe not exist anymore, or there is one big explosion or something terrible going towards us and we don't see it yet. Well, we can be worried about anything which not exist and we don't see. The fact that we have next day every morning tell us that it's okay for now, even if something will happen in a very further distance away from us, in the deep space. By the time it reaches us, probably will pass so many years, and it will take a long time for it to reach till us, and meanwhile we will continue our existence on our planet. However, we need to not forget that all these changes, the travel of us around our galaxy center, traveling our galaxy through the space of the universe, is affecting us. And we, human beings and all beings on our planet, affected by these changes in the space.